In these couple examples, we are going to be talking about finding some limits. We're going to try to see if we can do them kind of more analytically, and we're going to connect it to a graph, right? So we're going to put all these kind of pieces together. So very first thing that I look to do if I'm going to do a limit is we're going to be talking about, do we have any domain issues, right? Usually I'm just going to take this value and plug it right in. I'm going to take this value and plug it right in. Now these are a little bit different because I'm looking at values from the left and from the right. But normally I would just plug the 1 back in, but at the very beginning of this, if we take a look at the denominator, our denominator can't be if we factor this, or we just kind of mentally figure out what are our values that make the denominator 0. Our x is not going to be able to equal -1 and +1, which not coincidentally, those are the values that we're looking at. So that basically means that either we're going to have a hole or an asymptote at those individual x values. I don't know which ones yet, so let's do a little bit of work for this. So let's take this quadratic and let's go ahead and factor it. So if we were to factor this, we need two numbers that multiply to 3 that add to -4. So we would have an x minus 3 and then an x minus 1. And then if we factor the denominator, it's a difference of squares. So we have an x plus 1, x minus 1, and there's our thing. So we have, there's our -1 and there's our +1 for our domain issues. And the +1 is going to make a hole versus the -1 that's still going to be there is going to make a vertical asymptote. All right, so the hole, the limit's going to exist. The vertical asymptote, I don't know. So it kind of depends. So here's what we're going to do. So here is kind of our simplified version of this. So if I'm going to plug in 1, I know that 1 is going to make a hole and the limit exists on something like that. And I couldn't plug it into this one because if I did, I'd get a 0 over 0, which kind of screams hole. And so if I know that I'm going to get a hole, that means I probably have some sort of a factor that's going to cancel out. So we have a simpler version. So now we're really going to be doing the limit as x approaches 1 of x minus 3 x plus 1. And so since we know 1 is okay to plug into this one, we just go ahead and plug it in. So we have a 1 minus 3 over 1 plus 1 equals a -2 over 2, which is equals -1. So that's what we would have for that. We're going to do a visual connection to kind of make some sense out of all this stuff here in a minute. And then if we look at the next one is our vertical asymptote. So that's different. So, you know, if we have one side we're looking at on the left side, does this graph go up or does it go down at that side? I can graph it, but I can also see if I can kind of analytically figure this out. So to do that, this is the equation that we're doing. So we're doing the limit as x approaches -1 from the left of x minus 3 over x plus 1. So if we're to the left, we're going to plug in a value that's to the left of -1. So -1.1. All right, so all I'm trying to do is to see, does this value, it's an asymptote, so I know it's either going to go to positive infinity or negative infinity. I'm just trying to get an idea of which situation I have going on. So if I plug that in, I'm going to get a -1.1 minus 3 over a -1.1 plus 1. Okay, so this is getting me a negative something, right? Just a negative number. I don't really care that it's exactly -4 point something. Well, okay, we'll just write it. So we're getting a -4.1. Most important part of this is it's negative. And then at the denominator, we're getting a -0.1. So the idea would be that I would plug in another value, maybe make it -1.01. So this is getting infinitely close to -4, and this is getting infinitely small. So that's how we're really going to analyze to figure out what do we got going on. So we have a negative value divided by a negative infinitely small. All right, so the negative divided by the negative is going to cancel, and anything divided by something that's getting infinitely small is making the fraction infinitely big. All right, so that's what should be happening on that side. And then if we do this one, we're going to be now doing the exact same thing. This time we're going to be on the right side. So as x approaches -1 from the right, our x value of x minus 3 over x plus 1, our x could be a -0.9. That would be a value just to the right of it. All right, so we're doing the exact same thing, that if we plug it in, we're going to get a -0.9 minus 3 divided by a -0.9 plus 1. So we are looking at a -3.9 over a positive 0.1. Okay, so the idea is that if we get this closer and closer and closer to that -1, this value is getting infinitely small and this value is approaching -4. So it's going to just be a negative number divided by a positive infinitely small. So this time, negative divided by a positive is going to be a negative, and some constant value divided by something that's going to be infinitely small is going to be infinitely large. So negative infinity. So visually, let's do a little sketch here. We knew that we had, we go back to this, we knew we had a vertical asymptote at -1. At 1, we have a hole, which we figured out over here because they canceled. And so if you were to plug in 1, you would get a -1, except that would be a hole. Right? And then if you did some pre-calc stuff, our end behavior, our x's, our end behavior would be a 1/1 if we take the constants in front. So we would add something like this. The numerator on this actually tells us what our x-intercept is. So we have an x-intercept at 3. And then we're looking at a graph that would do something like that. So there is our, on the right side, our graph is going down. So to the right of -1, we're approaching negative infinity. And then on the left side, we don't have any more x-intercepts. So that means our graph would have to be up here. And this agrees with, as we are on the left side of -1, which is what this is asking for, we are going to positive infinity. All right, so if we kind of put all the pieces together, we don't necessarily have to do a visual in order to come up with potentially what's happening around your asymptote. We can kind of use some logic to it. All right, and then the last little bit is we're going to do some trig versions of that. Same kind of thing. We're trying to figure out the limit as theta approaches 0 from the right. This time, what I'm going to do though is I'm going to rewrite cotangent as cosine over sine. Right, and then because what I can do is I can look at the individual pieces again. So I'm comparing the numerator with the denominator. So here's kind of how I'm going to do this. Here's a sine curve. Here's a cosine curve. And now I can kind of look at what's happening when we're approaching 0 from the right. All right, so if we're approaching 0 from the right, cosine is approaching 1. So we're getting infinitely close to 1. And then approaching sine, we're approaching 0 on sine, we're getting infinitely small from a positive. So we're positive infinitely small. So a positive infinitely small is some kind of value. Doesn't matter that it's 1, just a value divided by something that's getting infinitely small is going to make the whole thing infinitely large. And we have a positive over positive. And so from the right side, we would have a positive infinity. And then we did the exact same thing, cotangent. Now we're looking at it from the left side. Same idea. Not x, theta. So theta is approaching 0 from the left of cosine over sine. All right, so we're going to logically think this through. So let me put the other side of these curves. Like that. And then cosine would be like that. So if you are approaching 0 from the left on sine, you're getting infinitely small, but you're getting infinitely small from the negatives. So a negative infinitely small. And then on cosine, you'd still be approaching 1. So we're looking at 1 divided by a positive divided by a negative, so it's a negative. 1 divided by something infinitely small is going to be infinitely large. And so if you were to actually graph cotangent, you would see on the right side, you have an asymptote that goes to infinity. And then on the left side, you'd have an asymptote that would be going to negative infinity. And you could see that by graphing a cotangent graph. But we don't always have to graph. We can just kind of analyze what's happening with the individual pieces.